Hey math kids, today we're going to talk about sets. We're in section 2A in your book, and we're going to start with example 1. So we're given two sets. P is all the letters in the word amateur, spelled A-M-A-T-E-U-R, and then Q is the set of all letters in the word team. Now, there's some things we have to get used to here. With sets, we only write one of each letter. So I'm going to say A, M, T, E, U, R. So even though there's two A's in the word amateur, we're only going to write it once because that's what set theory says. Only one of each type of element. Team, all the letters are different, so we can write all of those. So that's what it's asking you to do on part A. So I guess the answers are these two things for part A. Now part B is written like this. N of P, N of Q. I guess this should have been a capital Q. Sorry about that. Capital P, capital Q. Now all this is asking, it's a concept called cardinality, and it's asking how many elements are in each set. So all we're going to do is count how many letters showed up. So 1, 2, 3, 4, 5, 6. So the answer to this one is 6. And then we're going to go to Q, and we're going to count 1, 2, 3, 4. So part B, where it's asking for those two things, just count the elements in the set. Now, on part C, it says decide whether the statement is true or false. So we have this statement that is U is contained on, so it kind of looks like an E. Look in your book to see exactly what it looks like. But is U contained on set Q? So we go to set Q. Is there a U inside of this? No. So we're going to say that one's false. Okay, there's another one. R is not contained on Q. So once again, we go to Q. Is there not an R? There is not an R, so that is true. Hopefully this is making sense. Now we have another concept. We have subset. So P is a subset of Q. So what that means is that all the elements in P are found in Q. So we're going to go one at a time. Okay, A is found in there. M is found in there. T is found in there. E is found in there. But U isn't and R isn't. So P is not a subset of Q. And so the answer is false. Okay, and the last one, Q is a proper subset of P. Now, just the nuance between subset and proper subset. Proper subset means that all the elements, let's talk about subset first. So for subset, where the line's under it, means that all the elements in the first one are found in the second one. So in this one, all the elements of P are found in Q, and you go through this process that we did right here. But they could be the same set. So for example, this is a true statement. P is a subset of P because every element in P is found in P. That seems a little bit silly, but that is a subset. Now this is not true. This is false. P is not a proper subset because just like when we're talking about less than and equal to and less than, where we're talking about those two symbols, you can get really close when we're less than, but you can't actually touch it. Now, if we're less than or equal to, we get right up to the number we're talking about. That's how subset and proper subset works. So for a subset with the line under it, you can have the same set. For a proper subset, you actually need to make sure that set is smaller. So right here, back to the problem. So this is example 1, part C, part 4. Q is a proper subset of P. So that means that, one, all the elements in Q need to be found in P, and also Q cannot be the same set as P. Now we know Q and P are different sets, so we don't have to worry about that. And all these three letters, T, E, A, M, are found T, E, A, M, and so this one is true, because all the elements in Q are found in P. Okay. Now, I guess that's everything in that section. If you need additional help, come to Math Lab and Calculator.